Appreciate everybody being here, and I wish I could see y'all in person. You know, I love people, and it's a shame we can't get together, but hopefully next year we'll be able to see each other face to face. So I wanted to talk some about lance nematodes today, and lance nematodes are one of what I call the big three, the three predominant nematode problems on turf grasses, especially here in Florida. Sting nematode and root knot nematode being the others. And I think you just heard about root knot nematodes in the previous presentation a little bit. So I want to kind of talk a little bit about why we're doing the particular research we're doing. These are lance nematodes, and they're kind of different from either root knot or sting nematodes in that one of things being at me every time they send a message on this chat thing. I don't know how to turn it off. Anyway, lance nematodes are a nematode that lives out in the soil, but it also goes inside of roots. Okay, so the ones you see there in the middle are ones that we've extracted from soil. If you look on the bottom right, you'll see lance nematodes that are inside of a Bermudagrass root, tunneling around inside there. And then on the bottom left, you see the egg of one of these nematodes is getting ready to hatch. And you can find these eggs out in the soil and inside the roots. So this nematode kind of moves in and out of roots all the time. And I've never been really confident in the accuracy of the thresholds we've used for this nematode because it kind of goes in and out all the time. We're never sure how many are in the roots versus how many are in the soil and things like that. This is the type of damage that's associated with lance nematode as they tunnel around in the root and feed on the root. The root tissue collapses, fungi come in, it turns rotten and nasty looking like the ones on the right. You see there's no feeder roots there, whereas on the left you get these nice fine white feeder roots there that are actually taking up water and nutrients. So the grass declines then because it can't take up what it needs from the soil. Now, one thing that's happened in the course of the last number of years is that we've launched these new nematicides. Back when I started here at University of Florida, Nemacure was our standard nematicide. And Nemacure had both contact and systemic activity. And so it would kill and affect lance nematodes outside of the root in the soil, but it would also get taken up by the plant and get the ones inside the roots as well. Okay. Now, our new nematicides don't work that way, and they tend to have more selective activity. And we really don't currently have any good systemic nematicides that are going to get ones inside the roots. Okay. So in 2016 was the year that Bayer launched Indemnify, and Syngenta launched Divinyl, which have become the two predominant nematicides used on golf courses for the past several years here. And what I wanted to show, these are samples that have came into our nematode diagnostic lab here at University of Florida. If you see this on the left, you'll see prior to 2016, that was the 10 years prior to that. And you'll see that samples that came from golf course Bermudagrasses, that blue part of the pie, 57% of them are coming in at low risk of damage. Okay, these are either no or low risk of damage. Okay, and then the gray part of the pie there, only 17% of the samples we were getting came in at high risk of damage. Now, if you look over on the right, in 2018, which is just a couple years later, as we started to use all these new nematicides, you see that is actually flipped. And currently, well, as in 2018, you see that 57% of the samples we received came in at high risk of damage, and only 21% were at low risk. Okay, so what this is indication is that our numbers of lance nematodes are blowing up. And we've seen that these new nematicides don't work as well on lance nematode, while they can work really good on sting or root knot nematode. And so this nematode is becoming an increasing problem. So we started this study funded by the GCSAA and the Florida Golf Course Superintendent Association and the Matching Grants Program. And we've looking at these questions: how much damage do lance nematodes cause? Okay, and are our current thresholds accurate? Should they be changed? What's the best extraction method? Most of you may be aware, but we've got this new mist extraction we're using for root knot nematodes, which is giving a much more accurate assessment of root knot nematode numbers. We're seeing if that would work for lance nematodes as well. Trying to find when the best time to sample for these nematodes to determine if the numbers mean something different on treated turf versus untreated turf. So a lot of questions here with this study that we're trying to answer, okay? So essentially we have two sites, one in North Florida at the Plant Science Unit in Citra, and the other one in South Florida at the Fort Lauderdale Research and Education Center, okay? At both sites, we have two experiments. One is an untreated experiment that receives no nematicides, and then the other experiment is one where we have plots that are treated regularly with nematicides. And so those treated plots get treated twice a year with Indemnify and 4 times per year with Divinyl. The Indemnify is applied in March and October, and Divinyl is applied May, June, July, and August. Okay. In both locations, we take 2 types of samples. We take samples for mist extraction and samples for soil extraction. We're also measuring root lengths 4 times per year. And then these measurements that the previous speaker mentioned, some of these things: percent green cover, turf quality, NDVI measurements. We're also taking true firm measurements as well. So a lot of measurements we're taking, and this is a lot of samples. We're actually going to end up with 5,000 nematode samples we've taken by the end of the study, and 2,000 root samples, and innumerable. We're going every 2 weeks taking all these turf performance measurements as well. So a lot of data here. And so this is our site up in North Florida. This is Sunday Bermuda grass infested with lance nematodes. And you can see this damage is pretty severe in this site. This is the site in Fort Lauderdale. This is Tiff-Eagle Bermuda grass. And you can see we just sampled it. Here's why those little holes are everywhere. Our plots are 2 feet by 3 feet. And each time we sample, we take 4 plugs from each of these plots. And there's 60 treated plots and 60 untreated plots at each location. And you see that in general, the grass in Fort Lauderdale looks a lot better than the grass in North Florida. Okay. Let's look at some data. Now, I'm not going to throw statistics at you at this juncture, but I just want you to kind of pay attention to trends here, okay? You'll see that the orange and the blue lines are from our North Florida site. Okay, the orange line is the soil that's been treated with nematicides regularly, and the blue is our untreated soil that gets no nematicides. And then the yellow line and the gray line are from Fort Lauderdale. And again, the gray line is untreated, and the yellow gets treated regularly with nematicides. One thing you'll notice is that we started off with higher nematode numbers at our North Florida site. However, the South Florida site was well beyond our current high-risk damage thresholds when we started this study. What you notice is that during the course of this study, our nematode counts in Fort Lauderdale have went down, whether they got treated or not treated, and to actually currently they're below damaging levels, okay? And that's probably why that site's looking a lot better than the other one. So, but in North Florida, our numbers were high and continue to be high on this grass. One thing I will mention, not showing any root data here, but in general, our North Florida site has much more extensive root system than the South Florida site, even though the South Florida site, the grass looks better. So go figure what that means. But one thing you'll notice in looking at the treated versus untreated in both sites, you see that these nematicides are not controlling Lance nematode. Okay. Now, I wasn't expecting them to, and I actually, one of the reasons we're doing this is because these nematicides do not work very well on Lance nematode. Basically, we find that Indemnify really has no activity on Lance nematodes, and abamectin in Divinyl is functionally doesn't work very well. It just doesn't get down deep enough in the soil where this nematode typically stays. And so this kind of goes along with patterns we've seen in previous research where these products don't work very well on Lance nematode. However, in both of these sites, we also have root knot nematodes. Okay, and I'm not going to, again, just for time, I'm not showing you a bunch of root knot data. I got all this root knot data too. But the treatments are working on the root knot nematodes. Okay, so just kind of put that in the back of your mind. That there are some root knot nematodes in these sites that can kind of, and you're never going to find in these field sites just one nematode. Okay, so that may have something to do with some of our results coming up. Okay, these NDVI measurements are a measure of turf stress. Okay, and this is now looking at our North Florida site. This is our Sunday Bermudagrass where we had higher nematode pressure. And you'll see here, again, looking at our orange line, which is treated with nematicides, and the blue, which is untreated. And you see that, in this early part of the year, you see that the orange line is higher than the blue line, that there's actually statistical differences there. However, as we move later in the year, if you look like from August of 2019 up until about May of 2020, you'll see the blue line is higher, okay? And the untreated grass was actually outperforming the treated grass during that time frame. And then you see in June now our treated is looking better again, okay? Now, why that is, remember I told you those root knot nematodes are there. And so our treatments are actually, particularly the Divinyl, is working really well on these root knot nematodes. And so that's why we're getting turf response while we're treating for the root knot nematodes. However, once we quit treating, then the untreated starts looking better, because now we're back to having all these Lance nematodes as a major problem. So that's kind of some of the differences we see there in our North Florida site. This slide is showing our South Florida site. Remember, our nematode pressure from Lance nematodes kind of fell out, okay? And you really don't see much differences at all throughout this whole study here from treated versus untreated, okay? But again, in both the treated and untreated, they all went down. Now, this is some interesting stuff here, is that these are nematode counts from last June 2019, and how they impacted turf performance in March of 2020. Okay. Now, again, we got all these dates. I just picked out a few things to show you. And you see here that our nematode counts, I have them broken down into categories, less than 0, less than 100, 100 to 199, 200, 299, etc. Okay. And you'll see that when our counts got over 100 per 100 cc's of soil in June, it caused a decrease in turf performance the next March, which is kind of interesting. You could actually see long-term effects from one year to the next year and how the turf is going to perform from these nematode counts. This is the untreated grass. If you look at the treated grass, you see that you really didn't start getting a reduction in turf performance until we got over 300 Lance nematodes. Okay, now this is telling me that the treated grass tended to be more tolerant of the nematodes than the untreated grass. Okay, so we're seeing these numbers mean something different if the grass is treated or not treated. These are the numbers in March versus the turf performance in March. And you see that we didn't have any low numbers. Okay, so we don't know what they would have been if we had any counts that were less than 100. But you see here that once we got past 200, you see them going down significantly with Lance nematodes. And that was on the untreated grass. On the treated grass, we tend to have a lot more variability. And you see that we didn't start getting a decrease in quality until we got much higher numbers. So again, it seems that our treated grass tends to tolerate these lance nematodes better. Okay, some general observations. Again, I could, I don't know how much time I could spend doing all this data we got, but in general, what we've been seeing is, I didn't show you the miscounts, but generally soil counts tend to be more reliable predictors of lance nematode damage than soil counts. And that's because when the grass is severely damaged, we got no roots and the grass, there's no nematodes there, which really throws this miscounts wacky. Okay, generally our treatments are not very effective, our current treatments for lance nematode. However, we did find that treating the turf does, because you're controlling other nematodes, helps the grass tolerate the lance nematodes better. So even though we're not controlling lance nematode, we still are seeing a benefit from the nematicides because we're controlling other nematodes. And there'll be a whole bunch more data coming, but that's kind of where we're at with that study. I want to acknowledge my staff and my people who have done all the hard work on this project. And with that, I am finished. Thank you very much.